بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are exercises about section 1.1. This is a function in question 34, g of x equals x over square root of x plus 1, and we need to find g of 0. To find g of 0, we replace x by 0. So we have 0 over square root of 1, which is 0 over 1, which is 0. To find g of 3, we replace x by 3. So we have 3 over square root of 3 plus 1, which is 4, and square root of 4 is 2. To find 5 times g of a, so 5 is there, and it is multiplied by g of a. So now we replace x by a. So we have a over square root of a plus 1. And we can leave it like this, or we can multiply 5a over square root of a plus 1. Remember, when you multiply two fractions, a over b times c over d, you multiply the numerators over the product of the denominators. So this is 5 over 1. Now, how to find half times g for a, g of 4a. So half is the number outside, so I leave it outside. And now how to find g of 4a? I go to g of x and replace x by 4a. So I have 4a instead of x. And in the square root, I also replace x by 4a. So that's the answer. I can simplify 4 over 2 will give me 2. So the answer would be 2a over square root of 4a plus 1. G of a square. Well, I go to g of x and replace x by a square. So I will have a square over square root of a square plus 1. So this is g of a square. G of a all square. Now, g of a all square would be, what is g of a? It is a over square root of a plus 1, all squared. So this would be a square over, when you raise the square root to power 2, square root disappear, and we have a plus 1. Remember, a over b to the power n is equal a to the power n over b to the power n. These are some old formulas. G of a plus h. Well, again, I go to g of x and replace x by a plus h. So a plus h over, I have also x in the denominator, so I replace it also by a plus h, so that's the answer. Finally, g of x minus a. G of x minus a. Similarly, I go to g of x and replace x by x minus a. So I have x minus a in the numerator over square root of x plus a. I replace x again by x minus a, and then I have plus 1. So that's the answer of question 34. Another question, 35. This is f of x given, and find this quantity, the difference quotient, and simplify your answer. Well, let us find first f of 3. To find f of 3, I replace x by 3. So this is 4 plus 9 minus 9. So it is 4. So f of 3 is 4. Also, let us find f of 3 plus h. To find f of 3 plus h, I go to f of x, replace x by 3 plus h. So it's 4 plus 3 times 3 plus h minus 3 plus h all square. So I replace each x by 3 plus h. And now I simplify this. So this is 4 plus 3 times 3 is 9. And 3 times h is 3h minus. Now let us expand the square of a binomial. The first term squared is 9 plus 2 times the first term times the second term. So it's 6x plus h squared. So remember that whenever you have a plus b squared, you write it a squared plus 2ab plus b squared. This is an important formula. Now you can expand, multiply negative by each of these terms. Now let us find f of 3 plus h minus f of 3 over h. F of 3 plus h is here. So 4 plus 9 is 13 plus 3h minus 9 minus 6h minus h squared. You multiply the negative by all the terms. Minus f of 3. Well, f of 3 is 4. Okay? Over h. 13 minus 9 is 4. Minus 4 is 0. So these three terms cancel. And 3h minus 6h is negative 3h and negative h squared over h. Now I can take h as a common factor and I will have negative 3 minus h over h. H cancels with h and the final answer is negative 3 minus h. Here find the domain of each function. The domain set of all possible values of x. This is a fraction. We cannot accept that the denominator is 0. So the denominator cannot be 0. Let us factor the denominator to find the zeros of the denominator. This is x squared minus 9, difference between two squares. So x minus 3 times x plus 3. Remember, whenever you have a squared minus b squared, you factor it using a minus b times a plus b. This is called difference between two squares. Now, for the denominator to be 0, x minus 3 could be 0. So x is 3. And x plus 3 could be 0. So x is negative 3. So x cannot be 3 and x cannot be negative 3. So what is the domain? Set of all real numbers except positive and negative 3. I can write this in interval notation. If this is negative 3, I don't need it. If this is 3, I don't need it. And I need all the other real numbers. So I can write it from negative infinity to negative 3, union from negative 3 to 3, union from 3 to infinity. So this is the domain written in interval notation. Again, this is a fraction. The denominator cannot be 0. To find the zeros of the denominator, I need to factor the denominator. These are three terms. Remember, to factor three terms, if the coefficient of x squared is 1, you factor x squared, it's x times x, and you search for two numbers. Their product is negative 21 and their sum is 4. 3 times 7 is 21. I need the sum is positive 4, so plus 7 and minus 3. Now negative 3 times 7 is negative 21 and 7 plus minus 3 is 4. So this is the factored form of this binomial. Now, what are the zeros of the denominator? X cannot be negative 7 and x cannot be 3. So the domain would be from negative infinity to negative 7, union from -7 to 3 union from 3 to infinity, or you just say all real numbers except -7 and 3. Now here I have a cube root. With the cube root, there is no problem. Cube root of -1 is -1. So we could have negative numbers inside the cube root or positive numbers. So all possible numbers, all numbers here are possible for t. So the domain here consists of the set of all real numbers. We don't have any problem with any number. Here we have a square root. For the square root, 3 minus t cannot be 0, cannot be negative. 3 minus t cannot be, it could be 0, but it cannot be negative. So it has to be greater than or equal to 0. This means that negative t is greater than or equal to -3. And then if you multiply by negative sign, you have to change the direction. So t is less than or equal to 3. Okay. So this is the first condition. Now I have another square root. So again, 2 plus t cannot be negative. So 2 plus t has to be greater than or equal to 0. This means that t is greater than or equal to -2. So I have two conditions. Let us see these two conditions on the number line. I have -2 here and 3 here, and this is negative infinity and infinity. T should be less than or equal to 3. So it is to the left of 3. And t should be greater than or equal to -2. So it should be here. So I have these two conditions, and the two conditions together must be satisfied. The two conditions are satisfied here in this interval from -2 to 3. From -2 to 3, t is greater than -2, and it's also less than 3. So the answer, the domain of this problem is from -2 to 3. That's the domain of this function. Here I have a fourth root in the denominator. Well, the fourth root is like the second root. This number or this quantity x squared minus 5x cannot be negative. Cannot be negative. If it is negative, the calculator will say math error. Fourth root of -1 is not real number. Also, this is in the denominator, so it cannot be 0. So the first step, I will factor x squared minus 5x. So it is take x as a common factor. I have x minus 5. So x cannot be 0 and x cannot be 5. These are the first two conditions. I have another condition, which is x squared minus 5x should be positive greater than 0. Now to solve this inequality, this is a quadratic inequality. X times x minus 5 should be greater than or greater than 0. Okay. Well, here I have two zeros, which is 0 and 5. If you choose a number between 0 and 5, say 1, for example, then 1 times 1 minus 5, which is -4, 1 times -4 is negative. So it's not greater than 0. Okay. So x times x minus 5 would be greater than 0 here and here. Okay. If you choose a number -1, it will make it positive. Or if you choose it 6, then 6 minus 5 times 6 is also positive. So the domain of this function is from -infinity to 0. 0 is not included because it makes the denominator 0. Union 5 open, also it's not closed, to infinity. So that's the 0 of this function. Here we have some piecewise functions. Evaluate f of -3. I have to find out whether -3 is greater than 0 or less than 0. It's less than 0. So to find f of negative 3, I use the first definition. So it's negative 3 to the power 2 plus 2. 9 plus 2 is 11. So that's f of negative 3. F of 0, here the equality sign. So I replace x here by 0. So f of 0 would be 0. F of 2. 2 is greater than 0, so I have to use this definition. So f of 2 is, I replace x by 2, so it's 2. F of 2 is 2. Now, sketch the graph of this function. Well, to sketch the graph of this function, I have to pay attention to the important number, which is 0, because to the right of 0, I have a definition which is x. So here we need to graph y equals x. To the left of 0, I have another function, which is x squared plus 2. Now, this is a straight line. At 0, if x is 0, y is 0. If x is 1, y is 1. So that's the graph of this line, y equals to x. Well, the equality sign is here, okay, with it. So this point is closed. Now to graph this function in this region from negative infinity to 0, I know that this is a parabola, okay, x squared plus 2. It is the parabola y equals x squared and plus 2. We will take the graph 2 units up. Anyway, I need to see at 0, if x is 0, what is this function? It is 2. So at 0, it is 2. And 0 is not there in this function. So I put here an open circle. Okay. I need to check at negative 1. At negative 1, it is 1 plus 2, 3. I need to check at negative 2. At negative 2, it is 4 plus 2, 6. So at negative 1, it is 3, like this. And at negative 2, it is 6. And this is this part of the parabola. So this is the graph of the parabola, x squared plus 2. But we need this portion, which is to the left of 0. So this is the graph of this piecewise function. Another example. Here, the important number is 1. Let us find f of negative 3. Okay, f of negative 3. Where is negative 3? Greater than 1 or less than 1? Less than 1. So f of negative 3 is negative 1. F of 0. 0 is less than 1. So f of 0 is also negative 1. And we need f of 2. F of 2, well, 2 is greater than 1. So I use this definition. So it is 7 minus 2 times 2. We replace, as usual, x by 2. So 7 minus 4, which is 3. So f of 2 is 3. Now to sketch the graph of this function, the important number here is 1, this number, okay? Because to the right of 1, I have a definition, which is 7 minus 2x. And to the left of 1, I have another definition, which is y equals to negative 1. Y equals to negative 1 is an easy function. This is the graph of this equation, is a horizontal line. So at 1, I will graph y equals to negative 1 from negative infinity to 1. And the equality sign is here. So this is closed. And this is the graph of the line y equals negative 1 in this region to the left of 1. To the right of 1, I have a straight line. This is a straight line. To graph a straight line, I need 2 points. Okay, 2 points. The first value of x to choose is always 1, the number here. Okay, the border 1. If you replace x by 1, 7 minus 2 is 5. So at 1, it is 5. 1, 2, 3, 4, 5. So it's 5 here. And remember, the equality is not with this different part. So I make it open. Okay. So at 1, it is 5, but it's open because there is no equality sign here. Now I choose another number here. For example, 2. F of 2 is 3. So at 2, it is 3. and this is a straight line, so it has to pass by these two uh, numbers. So that's the graph of this function, this straight line and this straight line. Find the formula for the function whose graph is the given curve, the line segment joining these 2 points. So we need to find the formula for this function, which has a curve line joining these 2 points. Well, if you know 2 points, then the equation of the line is y minus y1 equals m times x minus x1, where m is the slope of the line, delta y over delta x, change in y, which is y2 minus y1 over x2 minus x1. This point has coordinates x1, y1, for example, and this one x2, y2. You can make this x1, y1, and this one x2, y2. It doesn't matter. So the slope would be y2, which is 7, minus y1, which is minus 3, over x2, which is 5, minus 1. So this is 7 plus 3, 10, and 5 minus 1 is 4. So the slope is 5 over 2. Now you can choose any of these 2 points and put it in this formula. So the equation of the line is y minus y1, which is negative 3, so it would be plus 3, equals m, which is 5 over 2 times x minus x1, which is 1. Now he said find the formula for the function. Well, the function is y, okay, so I can replace y by f of x. So I will have 5 over 2 times x minus 1 times 5 over 2. And if you take 3 to the other side, it's negative 3. So the final answer would be f of x equals 5 over 2x, and negative 5 over 2 minus 3 would give you negative 11 over 2. So that's the required formula. If the point 5,3 is on the graph of an even function, so this function is even. If you remember, even the graph of an even function is symmetric about the y-axis. So if you know one point on the graph, 5 and 3, 1, 2, 3, 4, 5, 1, 2, 3, this is the point 5 and 3. The question, what other point must also be on the graph? If the graph is even, then it is symmetric about the y-axis. So we have to go 5 units to the left. So f of 5 would be equal to f of negative 5 would be equal to 3. So this is the other point that should be in the graph, which has coordinates. The x coordinate is negative 5 and the y coordinate is 3. So the answer, it is the point negative 5 and 3. While if the graph is a graph of an odd function and 5, 3 is a point on the graph, 1, 2, 3, 4, 5, 1, 2, 3. So this is a point on the graph. But the graph this time is a graph of an odd function. So it is symmetric about the origin. Symmetric about the origin. So if you draw a line, continue with the same distance, you should reach here negative 5 and negative 3. So this point has coordinates negative 5 and negative 3. So the point would be negative 5 and negative 3. Finally, determine whether f is an even, odd, or neither. You can use a graphing calculator or Dismus calculator to check the graph of these functions. If it is even, the graph would be symmetric about the y-axis. If it is odd, the graph would be symmetric about the origin. But how to determine whether this function is odd, even, or neither? We find f of negative x. We replace x by negative x. So we have negative x here and negative x raised to the power 2 plus 1. So we replaced x by negative x. We have negative x over. Now this negative to the power 2 will disappear. So we will have x squared plus 1. Now compare this function with this function. I can write this as negative. I can take the negative side, the negative sign outside of the fraction. Okay, so I will have negative times x over x squared plus 1, or negative times f of x, because this is f of x. So f of negative x equals negative f of x. So this function is odd. And if you sketch the graph, you will find that the graph is symmetric about the origin. Remember, negative a over b, you can write it a over negative b, or you can take the negative outside. So remember this important way to deal with the minus when it's multiplied by a fraction. Another function to check whether this function is even, odd, or neither, we immediately find f of negative x. Replace x by negative x, replace x by negative x. Now, is this function equal to this function? No, it's not equal to f of x. If we take the minus sign outside, okay, if we take the minus sign outside, we will have x over negative x plus 1. This minus cannot be taken outside, okay? So is this equal to negative f of x? No, it is not. So this is f of x. To find negative f of x, you multiply f of x by negative. So you write it here, or you take it up, or you multiply down, okay? So it would be negative of x would be equal to this, or it would be equal to this, or it would be equal to this. And in all the three cases, it's not equal to this, because we have here negative x plus 1. So f of negative x is not f of x. F of negative x is not negative f of x. So f is neither even nor odd. And if you sketch the graph of this function, you will not find it symmetric about the y-axis, and it will not be symmetric about the origin. Another function, f of x. Let us find f of negative x. We replace x by negative x, and we replace x inside the absolute value by negative x. Well, this negative x is there, but there is an important remark to notice. Absolute value of negative x is actually equal to absolute value of x. Absolute value of negative 3 is equal to absolute value of 3. So absolute value of negative x can be replaced by absolute value of x. Now, this minus sign is multiplied by this, and this is f of x. So this is negative f of x. So f of negative x equals negative f of x. So this function is odd, and the graph is symmetric about the origin. The last example, let us find f of negative x. So 1 plus 3, replace x by negative x, and here also replace x by negative x. So I have 1, and this minus sign is raised to the power 3. So it comes out, because negative 1 to the power 3 is negative 1. So I have negative 3 times x cubed. And this minus is raised to the power 5. So it doesn't disappear, it comes out. And if you multiply this minus, when it comes out times this minus, I will have plus, and I will have x to the power 5. Now look to this function. Is this equals f of x? No, this is not f of x. Okay, what is negative f of x? Let us find negative f of x. You multiply by minus everything. So you have negative 1 minus 3x cubed plus x to the power 5. Now compare this with this. Is this equal to this? Of course not. This is negative 1. This is 1. It is not the same. The only problem with the 1 here. So f of negative x is not equal to negative f of x. So f is neither even nor odd. You can notice that we have x cubed and x5, although this function is neither even nor odd. Because of what? Because of this one. Actually, this one is multiplied by x to the power 0, and 0 is even, not odd. So whenever you have a number with the odd powers, the function is not going to be odd. That's the end of these exercises. Thank you very much.